In music theory jargon, an interval is defined as the difference in pitch between two notes. And two intervals are considered identical as long as their sizes are the same, even if the starting and ending notes are different. But despite having a rather simple definition, intervals are arguably one of the most important concepts in music theory, as they represent the building blocks for writing melodies and constructing chords. In fact, the two types of intervals are melodic intervals, where the notes are played one after the other, and harmonic intervals, where the two notes are played simultaneously. Having a thorough grasp of intervals allows us to better understand music and can ultimately make us become better composers. So, what are the different intervals then, and how do we identify them? Every interval has its own name, which consists of two parts, the quality and the number. The combination of these two elements is what distinguishes unique intervals from one another. Let's first focus on only the number part. Since intervals measure the difference between two notes, intuitively you might think that the number simply represents the number of semitones that separates the two notes. So, for example, the number of semitones from C to E would be 4, since you have to pass through C sharp, D, and D sharp before reaching E. But this is incorrect. The numeric size between two notes is actually the number of lines and spaces the interval encloses on its staff, including both the starting and ending notes. Therefore, the easiest way to determine the number part of an interval is by looking at where the two notes sit on the score and by counting the number of lines and spaces you would have to traverse to go from the first note to the second, starting with the number 1 at the first note. So the number element of the interval between C and E is actually 3. When determining the number part, you don't have to worry about any accidentals. This matters only for the interval's quality. Thus, all three of these intervals would have a numeric size of 3. Lastly, an interval with a numeric size of 1 must have the same starting and ending note. Now let's focus on the quality part of an interval's name. Intervals with a numeric size of 1, 4, 5, and 8 can have a quality of either diminished, perfect, or augmented, where each successive quality indicates an increase in size of one semitone. Intervals with a numeric size of 2, 3, 6, and 7 can have a quality of either diminished, minor, major, or augmented, where, again, each successive quality indicates an increase in size of one semitone. Since an interval with a numeric size of 8 is just an octave, a 9 would effectively be the same as a 2, just an octave higher. Recall that the number 1 is reserved for intervals with the same starting and ending note. This means that, just like a 2, a 9 can also have a quality of either diminished, minor, major, or augmented, and we can further draw similar conclusions for intervals of even greater sizes. In order to determine the quality of an interval, you should first build a major scale whose tonic is the bottom note of the interval. So in our earlier example, you would build a C major scale since C is the bottom note of that interval. Next, you determine if the top note is within the major scale that you just built. If it is, then the quality of the interval is either major or perfect, depending on its numeric size as discussed earlier. In this case, the E is indeed one of the notes found in a C major scale, which means that this interval is a major 3. If the top note was a G, then the interval would be a perfect 5. And if the top note was a C, then the interval would be a perfect 8. If the top note is not found within the major scale, first determine what note would make that interval either major or perfect while maintaining the same numeric size. Then determine how far away and in what direction the actual note is. Let's say the top note in our earlier example was E flat. We know that the number part of this interval is still a 3, and we know that a major 3 would have E as its top note. Since the actual note, E flat, is one semitone lower than E, effectively making the interval one semitone smaller, this means that this interval is actually a minor 3. If the top note was E double flat, which is 2 semitones lower than E, then the interval is actually a diminished 3. Similarly, if the top note was E sharp, which is one semitone higher than E, effectively making the interval one semitone larger, then the interval is actually an augmented 3. Although E sharp isn't harmonically equivalent to F, if we rewrote the top note of this interval to be F, this would no longer be an augmented 3, since the number part of the interval has changed. Instead, this would be a perfect 4. Sometimes it can be a little difficult to build a major scale using the bottom note of the interval as the tonic. For example, if we had an interval like this, we first determined that the numeric distance is 7. Then, following the method that we established earlier, we would have to build an A-sharp major scale. Although an A-sharp major scale does exist, it would be quite tedious to work with a key signature that consists of 4 sharps and 3 double sharps. Instead, we can swap out the A-sharp for an A natural since working with an A major scale is much easier. After we build our A major scale, we can see that G sharp is indeed one of the notes found in our scale, which means that this interval is a major 7. Then, in order to go from this interval to what we had originally, we would have to bring the bottom note up a semitone to A sharp, effectively reducing the size of this interval by a semitone. If we go back to our sequence of interval qualities for numeric sizes of 2, 3, 6, and 7, ordered from smallest to largest, we see that an interval that is one semitone smaller than a major interval is a minor interval. Thus, the jump from A sharp to G sharp is a minor 7. Let's go through one more example. First, we determine that there are 5 lines and spaces separating the 2 notes in this interval. Next, we build a B-flat major scale and conclude that the top note of this interval is not in that scale. If we wanted a perfect 5, our top note would have to be F natural. Since the top note is actually F flat, our interval is one semitone smaller. Going back to our sequence of interval qualities for numeric sizes of 1, 4, 5, and 8, ordered from smallest to largest, we see that an interval that is one semitone smaller than a perfect interval is a diminished interval. Thus, the jump from B flat to F flat is a diminished 5. Here are a few exercises for you to practice identifying intervals. Pause the video and see if you can solve them before the answers are revealed. As a side note, we usually refer to the number part of an interval as an ordinal number. So a perfect 5 is actually called a perfect 5th, a minor 2 is called a minor 2nd, and so on. By now, you may have realized that this method for classifying intervals, although rather straightforward, is sometimes incomplete. For example, how would you classify this interval? We know that the numeric size is 6. We also know that a major 6 would have A natural as the top note, so A sharp would be an augmented 6. But what about A double sharp? Similarly, how would you classify this interval? We know that the numeric size is 5. We also know that a perfect 5th would have G as the top note, so G flat would be a diminished 5th. But what about G double flat? The truth is, these intervals don't actually have a name. But luckily, they're also virtually non-existent. The first interval is inharmonically equivalent to a major 7th, which is a far more common way of spelling out this interval as opposed to whatever this is. And the second interval is inharmonically equivalent to a perfect 4th, which is also a more common way of spelling out this interval as opposed to how we wrote it originally. Admittedly, some intervals are more rare than others, but having a thorough understanding of them all will help you go a long way in your musical journey. So the next time you need to play a B-flat half diminished 7th chord with a flat 9, hopefully it doesn't take you as long to find every note.